Today I'm here to speak about Micro Frontends. So any of you ever heard about Micro Frontends? I see some hand. Oh yeah, just two. Cool. So then yeah, you will probably find this interesting. So let's start. Anyone still uses jQuery here? Yeah, yeah. That unfortunately is a good one, because today I want to show you how to move on from that. Also, yeah. Next to jQuery, it's Ember. So people also still use Ember.js in their every. Yeah. So people still use Ember.js in their everyday work. So in their applications. And there's Backbone.js. We thought that Backbone.js is dead many years ago, but yeah, it's still here. And yeah, also the Angular 1. So there are a lot of applications still running in productions with the Angular 1, and people are struggling to migrate from all those, let's say, old technologies that are not fun anymore. So when you say to someone that you use Angular 1, it's probably this is their reaction, or jQuery or Ember.js. So by the time front-end and applications in general changed a lot. So we now have more state in our front-end applications. They are re-rendering all the time. There's a big communication with the back-end API. A lot of things are happening there, and it's hard to handle those things with some old frameworks like or libraries like jQuery. So today we want something new. There's also a funny thing. I found if a developer fell asleep 10 years ago and then woke up today, he would really find that applications are more complex today. So for handling those complex applications, we want to use something like React.js or maybe Vue.js. I know that Vue.js is the most popular library for PHP developers. And also some newer versions of Angular. And it's really hard to come to your boss and say, hey, we want to rewrite whole application to something else and give us 3 months. So you probably get a negative response from him, and it would be really hard for you to migrate to something new. But yeah, today I want to show you how can we migrate from those old front-end technologies, and how can we use something new and scale our front-end applications. So today I want to present you the Micro Frontends. It will be our solution to the problem. So who am I? Just a bit about me. I'm Ivan. I'm living here in Belgrade. I'm working remotely as a consultant. So I have my own agency, IGN Consulting, and I'm also working with Nearform. It's a company based in Ireland. They're also doing consultancy work. We work mainly with JavaScript. And also I'm making JS remotely. So if you maybe want to change your career and go to find some JavaScript job that's remote, so working from home, you can find a lot of them on JS remotely. You can also follow me on Twitter, check my blog. I write about those nice things a lot on my blog. So let's move on. What are Micro Frontends? So the obvious question. Micro Frontends, as I said, is a microservice approach to the modern web. So we need to start from a microservice. So what exactly what are microservices? Just the architectural style that structures your application as a collection of a loosely coupled services. So microservices, just architecture style, where you have a lot of small applications that communicate and work together and serve, so do something for the user together. So since I'm JavaScript developer, this is how usually some microservice architecture looks in Node.js. So there are, for example, three Node.js applications. They are exchanging data, and they're working together and serving some content to the user. Or even if we want to have them to be loosely coupled, meaning that they don't need to know, so one service doesn't need to know what are other services on the server there, and if they want to communicate together without doing some registration between them, we can use event buses. This is like how microservice architecture looks like most of the time. So as I said, this event bus is allowing us to have this publish-subscribe style communication between those small applications between those components without requiring them to register one with another. So if you want to add one more service, so just put that service online and connect it with the event bus, and that would be all. So what are the microservice principles? First thing is lightweight protocol between services. So something small and nice that you can use to exchange data between the services. People usually use just REST API, so HTTP protocol, or you can use something more real-time, or you can use just an event bus. Next thing is we want to have small services, so people tend to make them really small and give them just one job per service. So you will have like service for handling users, so just handling session, registration, login, and that's it. If you're building e-commerce, you will have one service to handle orders, one service to handle products, and then connect them and serve your e-commerce application. Then we want service independence. They're in production, so in the server environment, they are working together, but the main idea behind microservice is that you can pull a service down, run it locally, and it will work properly without any other service around it. So it will be much easier for you to work with that small piece of code, update it, test it, and then move back to the production. And yes, microservices, all those services should be easier to understand, develop, and test. You're probably seeing some big monolith applications every day where there are a bunch of tests, a bunch of methods there, classes, everything. And it's so hard sometimes to navigate and to find the right thing that you want to update. And you're probably afraid to update something, something else might break. With microservices, they should be much easier to understand because it's like 100 lines of code or maybe 200 lines, and that's all per service. So it should speed up development. When you have something small, you can easily update it, or you can create another small service, and then you will much faster put that code online. And finally, the microservices are enabling us to really use continuous delivery and deployment. So whenever some service is ready, you put it on some CI system, so the tests pass, and the service is going to be online. So really, whenever something is ready, it can go online. If something fails, you can just replace that service with some other, and so on. So it gives you that continuous delivery. So let's come back to this slide. So this is how microservices usually look like in the back end. But what will happen if we can have something like this in the front end? So the same way we have multiple small applications running in the back end, we can do the same thing on the front end. So we can have, for example, 3 React applications running in the same browser window and serving user, communicating together and being independent, but also working together in one UI. Or even we can do something crazy like this. We can create an environment with 3 different frameworks, so Angular, React, and Vue.js. So you can have like 3 teams. Each of them will use different technology, and then you will have one deployment system that will merge those 3 applications, deploy them, and they will be running together in the UI. But also you can, for example, pull out React application and run it independently. So most of the time we see blog posts like, which one is better, which one should you use, should you start with AngularJS, should you start with React, why is Vue.js the best, and so on. So from some conversation like which one is better, we can come to a conversation where we talk about how can we make them work together. So what's the best that we can take from React, what's the best we can take from Vue.js, and how can we combine them and put them and take the best of both worlds, or the 3 worlds here. So we are coming to the situation where we have microservices everywhere, so decouple everything in the front end and in the back end. How this looks like, so simple example, you have some application, let's say e-commerce one, and you have 3 features. So you have listing of the products, you have cart, and you have some list of the categories, for example. And those are some main 3 features that you want to show to the user when he comes to the page. We can rewrite this to look like this. So instead of the one big app, we have the root application that will be loaded immediately, and that root app will load 3 small applications like app 1, app 2, app 3, and each of them will serve something to the user in the same UI. So why do we want to do this? In this example, you have just one app, and that one application will be connected to the API, and in the backend, you'll probably have a lot of different microservices that will be working together and serving some data back to the API. So this one app will be taking data from multiple microservices. With the Micro Frontends approach, we have something like this. So each of those 3 applications can be connected to its own microservice. So in this way, you're decoupling the UI and also the backend stuff. And then you have a separate application. So this app1, microservice 1, can be a separate standalone application that one team can take and work on it, and then just move it back and update the whole environment. So that's really cool when you start getting more and more people in your company. You start decoupling things. Until like recently, we were not able to decouple front-end 2. But with this, we can decouple front-end 2 and have separate things here. And we can finally scale our front-end applications and also the whole environment that we have. So how did we get here? So I'm talking about decoupling front-end into different small applications. So why are we doing this? First thing, we had monolith full-stack application. We're still using it, so like PHP or Ruby or some other language is working on the server, and it's serving HTML to the front end, and that's all. Then we saw that our companies are getting bigger and bigger. You now have 30 people working on that monolith application. There are a lot of conflicts there. And then we saw that we need to separate something there. So we separated front-end and back-end applications. So now we have front-end and back-end developers that are working on separate things. So from 30 people, you have 10 people working on the front-end, 20 people working on the back-end. And they are working on different applications. They'll have conflicts using different code bases, repos, whatever. Then our company started to get bigger and bigger. We got more and more people. We wanted to scale our application to speed up the development. So we created microservices in the back end. So now back-end developers can split up into multiple teams. They can work independently on different things. And then React came to the world, I think 5 years ago, and we got components. So some decoupling happened on the UI too. You can have separate components and then reuse them, maybe have different people working on different components, so on. And now we have Micro Frontends. So we got components and we want to more separation in the front end. So we are now separating applications into separating big applications into smaller ones to achieve bigger scalability. And that's because we want to fight with the bad architecture. So if you create a monolith application as a startup and then you receive some big funding and then you hire 100 developers, it will be a disaster to put them to work on one monolith app. So that's why we need to start from the code and then start with, also with the organization and change stuff so we can achieve really good scalability and really good stuff together. So what problem does microservice, micro frontends architecture solve? So first thing, I think someone you said that you're still using jQuery. With the micro frontends, you can start small, so you can start rewriting some specific functionality in your UI into some new framework. So if you want to use Vue.js, just pick up some div or some part of the UI, and you can rewrite that easily into a new framework and put it back in, and then move on step by step. And after a couple of months, you will have everything rewritten to some new framework. The next thing is no more shared code bases and conflicts. As I said, in the front-end world, we're still having a lot of conflicts in our big front-end monolith applications. So with this, we can split up stuff also into multiple repos if that's needed, and then people can work independently on their own stuff. Next thing is independent deployment. So this wasn't really possible with the front-end app. You had to bundle everything and then put it on the server. With this, you can deploy independently your micro front-end app the same way like we do that in the back end. when something is ready or something break up, you can have your development team fix it and move it back. So just that one part, you don't need to redeploy the whole thing. And one good, or people say bad thing, is that you can each team can be responsible for their own stack. They can pick whatever they want. So it can be a good thing. It will be probably fun for team. They will be independent. They can use whatever. So one also the problem that's solved. And yeah, you can start to easily scale your front-end app. How do we split applications? So first thing, we can, as I said, we can do by some functionality. So if you have some main functionality, take it out, split it into a separate application. You can do by page. So a lot of companies do this by page. So they separate the whole page into a small micro front-end app, and then they have one big main router that's listening for the URL changes, and then mounting some new app in the UI. And also by some sections, so you can split up like sidebar, header, footer, whatever else there. And yeah, so now we know what are micro frontends, why do we need them, so what are some pros of the micro frontends. Let's see how can we do the implementation, and what are the tools that exist now there that we can use to easily start with the micro frontends. First thing is external app bootstrapping. So it's not like a real word. I just created this. It's going to show us how to easily, this is the easiest way to start without any library. Just write a couple lines of code and you can start with the micro frontends. Then iframes. So they're with us for many years, but we are giving a new functionality, so a new way of usage to the iframes. They are now helping us to use micro frontends. There is a single SPA library, so this is a JavaScript library that's, I think, the most popular one for building micro frontends. And we have Print framework, so this is something new. Some company from Netherlands created that, and they open sourced it, and it's like a real framework that you can use to easily set up. You have router and all the things inside Print. So let's go one by one and see what are those implementation details and how can we really use them. First thing, for the external app bootstrapping, here code lives on different servers. So for each of the micro frontend application, you will have different server where the code is going to live. Then here we can have independent deployment. Since we have different servers, we can set up a different CI for different repo, and we will have everything split up there. And for the communication, so we will have our micro frontend apps, and they will communicate with the API, but sometimes you need to share stuff between them. For example, you click on a button in one micro frontend app, and you want to see some response on some other micro frontend app. We need something to exchange data. So we can just use the window object. It's not the ideal thing, but yeah, every browser has window object. You can put stuff inside the window object and then read it from the window object in another service. And also, we have front-end implementation of the event bus. So a synchronized event bus where one service can put stuff in the event bus, and another service will subscribe to event bus and will be notified when something comes up for that service. As I said, you don't need much lines for this. So this is JavaScript code that's using jQuery as the simplest way to implement that. And this is just one function called fetch_app. So this function is taking element-based URL and the list of files that you want to render. This fetch_app will be used by this main application that will be rendered all the time. And the fetch_app will provide, so pulling the data from different server and rendering that micro app into a specific div. So you just need to tell where to render, so which element, and base URL, so where is the code living, what's the URL of the server, and also the files that you want to pull. Most of those modern frameworks are bundling the code. So at the end, you just get main.js and main CSS for every application. And then this is the main part. So just going through the files, and then if the file is JavaScript, just put it inside using Ajax function from jQuery. So just inject that into the browser, and also using this global method. So the micro app will expose a global function, and then using this global method, we will tell the micro app where to render. And if the code is CSS, so if the file is CSS that you want to pull, just create a link element into the head and put the code there. So this is the most interesting part. How do we tell the micro app where to render? Here is the React app, for example, and this React app is just exporting a function that takes an element. So this element here will be populated by the main root app, and React will know which div to use to render the UI, the code. So as you see here, we're exporting global app. So here, if the function name, so if the name of the micro app is app, it will receive, so this app function will receive the element and it will know where to render. How is this used in the root app? So simply, you just import the fetch app function that I showed on the first slide, and then just call. So for some first apps, we wanted to render this inside the div with the ID app, and the code is living on localhost 3000, for example. And then by calling this code, everything that's living, so main.js and main CSS living on localhost 3000 will be injected, and the application will be rendered in the div with the ID app. So it's really simple. So basically I wrote this code for when I was working as a consultant for some USA company where they had big Ruby on Rails application, and we wanted to easily start with implementing some React stuff. So we just created one simple function that was called by the Ruby app, and then each of the divs was populated with React code by using fetch app. So it's really simple to start. I said on the start that there is event bus implementation in the front end too, so in JavaScript, and it's called EEV. So it's open source on GitHub, and it's really small. So it has less than 500 bytes. It doesn't have any dependency, so it's really fast to use. Just have, and it's really simple. You just have one. So basically, you have you create one instance of the EEV, and you have two methods to send data and to subscribe to the event bus. As I said, it has 0 dependencies, and it's really simple. So you can find it on the GitHub, and then see that it's really the best thing for the event bus implementation that exists now. It's used like this. So just import it, create an instance, and then you have emit function and on function. Emit function is just sending some data to the event bus. This is just the key of the event, and this is the data that you want to send. E.on will subscribe to event with the name event, and this is just a callback function that will be executed when some data comes there. Also on my blog, you can see an example how I created Micro Frontend implementation with React and Angular, and then exchange data between React and Angular, and they were re-rendering when some app does something, the second one receives the data and does something, so on. Since in the first implementation there is no other way except sending EEV instance through the window. So each of the micro apps can just use window.e as instance of the event bus, and then use emit and on to send and receive data. Next one is iframes. So as I said, it's here for a long time, and we now have different use case for it. Here the code is also living on the different server. So the same thing, you deploy it separately, have different CI, so on. Independent deployment, and communication is done through the browser event bus. So the browser already has some functionality for us to send data between like the root app and the app that's living inside iframe. It's called post message. So you can use window.postMessage to send the data to the iframe, and also the application inside iframe can use this one to send data back to the main root app. There is the event listener, so the application that should be receiving data can use this event listener with the key message to receive messages from different apps. Here's an example, so simple HTML code with an iframe here, and some big script here. So let's zoom in what this script is doing. Just taking the instance, so the reference of the content window inside the iframe, and then using this app, we can use post message to send data to it. For example, this will not work because our iframe is living on example.com. So this second argument here is the origin. It has to match the root URL. So if you send something to the iframe with google.com, it will fail. It will tell you that you don't have iframe with the base URL google.com. But this one will work because you have example.com rendered on your page. And here also we have an event listener in the main app, which is waiting for some data to come back from the iframe. We have receive message callback, and then it's taking event as an argument, and it's checking the origin. So did we really get a message from the iframe living on the app, living in the iframe from example.com? Because using post message, if we don't do this, anyone else can just send some stuff into our application. So this is just a security check here. And then you can see the source, so it's iframe, and you can receive the data from the iframe, so whatever is sent. This is the code that will be living in the iframe, so almost the same thing. You have receive message checking if the origin is the same, and you get the source, so window.opener, that's the root app that opened this iframe, and the data that we sent. And then using event.source.post message, you can send data back to the root app. So it's a simple way to implement micro frontends and have some interaction between micro apps. Then next thing, single SPA library. As I said, it's like the modern solution to solving this. So this is really a library. You can find it on npm, easily install it. So the single SPA is open source. It's created by Canopy Tax. It's a company that started with this and then open sourced it. Then it gives us the ability to use the multiple frameworks on the same page without refreshing the page. Then we can write code using a new framework without rewriting an existing app. So the single SPA is good if you already have some modern framework running, or at least Angular 1, or I think the Backbone and Ember are also supported. So if you already have something like that, you can just put some small code on the top to implement single SPA, and then you can start adding more and more micro apps there. And this is a good thing. So previous two implementations will load the whole code immediately when the user comes to the page. So when the user comes to the page, if you have like 5 iframes there, they will be loaded immediately, and it might crash, it might be slower. With the single SPA, we can tell when to load each of those micro apps. So we will have lazy load implementation there. So as I said, it's on GitHub, and some things about single SPA library here. Code is living on the same server. So single SPA helps you to bundle everything together and do just one deployment. So a bit different way. And for the communication, this is a fun thing. We can use basically anything. We can use window object. We can use the EV event bus. We can use some shared states or Redux or whatever else we want, and whatever basically we want to use. Single SPA is, you can install it using npm, and this is how it works. So this is like the main thing that should be run when the user comes to the page. We have the single SPA start at the bottom, and then we declare all the child applications. And every child application should have an app name, loading function, and activity function. So here we have a loading function for our first app. A loading function is just a method that should, like lazy, so it should return a promise that imports some app. So if the single SPA wants to import your app, it just has to code the loading function. But since it's using an import, it will be asynchronously imported, so it won't be done at the same time. Then we have activity function. It's telling single SPA when to use this loading function. So when this function returns true, that means that single SPA has to call a loading function and to load the app and work with it. For example, here, this one is listening for the URL, so changes, and when the URL changes to, so URL path changes to #app1, then it will call the loading function and your application will be shown. This is the bottom, so just declaring the child application for each of the child applications and just calling single SPA start. Every micro app, so every single SPA application that's declared as a child app has to export 3 things. So first thing is the bootstrap method. The bootstrap app method is just preparing the DOM for rendering the app. Mount is just mounting, so injecting JavaScript code into that div. And unmount is when the single SPA wants to remove your micro app from the UI, unmount function will be called, and then you need to unmount, so the remove everything from the div. First thing, bootstrap, so how it works, it should just create an element, so div, inside the document, and put an ID and append something there that you want. So it prepares the UI for rendering the app. Next thing is mount. So in this example, we're just putting some text as an example inside that div. So when the mount is called, single SPA will just execute this code, and the DOM element, so this div that we created, will get app1 is mounted text on it. And when the single SPA wants to remove the app, then DOM element will just remove its text. So this is what should happen in those 3 methods. Sometimes it's hard to write those bootstrap mount and unmount for every app that you have. So guys from the single SPA team created small modules like single SPA React, so on, and that help us to immediately export bootstrap mount and unmount by providing some information from our React app. So single SPA React just takes React DOM dependencies, then your root component, so the root component in the React that should be rendered, and also where to render that component, and you get bootstrap mount and unmount, so which is really easy. If you already have some React app, you just need this file, and you need the single SPA root app file to declare this child app, and that's all. For the Angular, they have also for the Angular 1, but this example is for Angular 2+. You just need to declare where to render, some modules, router, other dependencies there, and you will get bootstrap mount and unmount immediately there, ready for usage. And Vue.js, you probably know that Vue.js is easiest to work with, and the single SPA Vue is also the easiest one, so it just accepts element that should be rendered and where should be rendered, and the template, so Vue.js template that you want to render, and that's all. You just need those 4 or 5 lines, and you get bootstrap mount and unmount for your Vue.js app. So this was everything for the single SPA. Let's move on to Frint.js, the last one from the implementations list. Frint is a bit more complicated. It's living on, you can find a lot of documentation in frint.js.org. It has CLI. So you can use Frint CLI to generate the whole, to bootstrap everything from scratch. You can use Frint CLI to create a new child app. It will be immediately connected. So a lot of, you can use Frint CLI to create more routes. So much easier to work with. It has routing, so single SPA or all other implementations, for them you will need to create some way of handling routes. I'm not sure, maybe single SPA created something right now, but they didn't have it. Frint has routing. It has state management, so it has Redux or something else already there. You don't need to install anything special. And it has server-side rendering. So you know that front-end applications are just living on the front end. With the Frint, we can use server-side rendering to get faster applications, to get better SEO. So Frint.js, they have a nice website with a lot of documentation, and they said it's modular JavaScript framework, so it's a framework, not just a library, for building scalable and reactive application. Frint CLI, so just use npm to install the Frint CLI, and then you can start with Frint new, then set the directory where you want to create a new project, and using --example, you can specify the name of some specific example that they provide, and the code will be immediately there so you can browse and use it as a starting point. The cool thing with Frint is the reactive programming. However, how many of you heard for reactive programming or maybe used it? Yeah, reactive programming is a cool way to have reactive applications that will be working. So there are a bunch of implementations like Rx PHP, Rx Ruby, Rx Java, JavaScript, and so on. So those Rx libraries are helping us to have like streams of data, and then our apps are listening to those streams, and then they're re-rendering, updating their state, and so on whenever something is changed in that stream. So it's like one way of implementing some kind of event bus. So this is the logo of RxJS, and Frint has that. So you immediately have a way to exchange data in real time between your micro apps in Frint. And also work with React Native. So if you're using Frint.js to build a React app, you can easily export this into React Native and then have Micro Frontends on your mobile application, which is crazy and cool at the same time. So this is what Frint gives us out of the box. We're almost done. So Micro Frontends is fun. As I shown you, it can help you, especially you that have work in big teams in big companies that are working on just one app. When you have like 500 developers working on one app, Micro Frontends can help you scale. But there are some cons, like there is more code and dependencies to maintain. So every micro app will give us more code, as obvious, but it will have more dependencies. If you have like 3 apps, each of them is using different framework, you have 3 different frameworks to maintain. When some new version comes up, you need to update one of your micro apps. If there's some big bug in React, you need to find which micro app uses React and then to update it and so on. Then there are big bundles. So when you have a standalone front-end application built, for example, in React, you have some dependencies there, but when you have 3 versions of React living in 3 different applications, everything, so all those, for example, React 16.1, 0.2.3, all those 3 versions will be bundled together in one big bundle, and sometimes it will be hard for, so most of the time, it will be hard for the browser to execute that big amount of code and render stuff. And yeah, performance, that's what I said on the start. So how can you split the front-end application, front-end applications into micro apps? People usually split that by page because of the performance. When you have more than like 2 or 3 micro apps at the same time on the page, there's a lot of JavaScript code, a lot of CSS stuff that browser has to process all of them. So that's why the good idea is to split up by page, and then when the page refreshes, re-renders, then just one micro app will be there. So you split up by page and you won't have that big issues with performance. And Micro Frontends is like a new topic, so people are still investigating how can we handle this performance issue. Almost done. Who is using Micro Frontends? So Micro Frontends is used a lot at Google, for example. They are, if you're using Gmail and then you see Hangouts chat on the site, that's being run by iframe, so that's a Hangouts totally different app that just being injected inside the Gmail UI using iframe. Or for example, Microsoft, they have a lot of small micro apps living in the front end. For example, Outlook application, when you use it and you receive an email from someone and you hover the name, you get some more information. So who is the sender, what's the email, and so on. That one pop-up is the micro app, and there is more than 100 people in a separate team or couple teams that work just on that one pop-up. And then there's a team that's, or there's a DevOps team that's just deploying their code, and it looks like it's just one app, but the pop-up, for example, is a micro app there. Facebook, so they have a lot of micro apps too. Even the share or the like button are separate React applications. Then there's dozens. So they're using, there's like company that creates Netflix for sports. So you can subscribe and then watch sport in real time everywhere in the world. And they are implementing Micro Frontends for handling a lot of users and handling all those performance issues that you can have. So their team is also giving a lot of talks about Micro Frontends. So if you search on Micro Frontends on YouTube, you'll find someone from Dozen explaining how they do it. And also Zalando. You already have a friend that moved to Berlin to work for Zalando. It's a big company, e-commerce, and they're developing their own tools for handling and open sourcing them. So they're handling Micro Frontends using Go, for example, using some big router that lives on their server and so on. It's really good what they're doing, and in that way they're handling millions of users every day. And yeah, many more. So basically, every big corporation that scaled a lot, they had to use Micro Frontends to also scale their front-end applications. So, conclusion, what we talked about today. If you have a simple application, so if you have a blog or if you have a small team, if you have some e-commerce app that's not being used that much, you have millions of dollars transactions every day, don't use this because it will be just a big problem for your team. 5 of the developers it will be hard for them to handle like 3 micro apps and all those dependencies. Only use this if you have like more than 20, 30, I don't know, and if there is a need to split up things because you have a lot of conflicts and you want to scale even more. So use Micro Frontends to make your life easier, not more complicated. As I said, if there is a need to scale, use it then. If not, then just stick to a monolith way. Also, Micro Frontends architecture doesn't mean that you should use every new JavaScript framework that comes, because every day we receive like 5 new frameworks and then people talk about them. That it's like hype-driven development. Everything that's new, you should put it in your app. This doesn't mean that, so you should be careful what tools you use and then create some good environment. And also, don't forget to make standard across those applications. If you have 3 teams working on different 3 things, at least have some standard between them, because when some guy comes from one team to another, he will immediately know what standards are also there, and it will be much easier for him to work with the new team. And that's all. Thank you. Thank you.
Thank you, Ivan. We have one question that we've got through the Slido.
Slido, yeah.
And that's the question Maverick was asking. How do you handle server-side rendering?
Cool. Yeah, thanks. As I said, in the implementations, only the Fringe.js enables you to handle server-side rendering out of the box. So first 2, like external live bootstrapping and iframes, you cannot render stuff using server. Single SPA doesn't have it, or maybe they created something. I wasn't checking. But for the single SPA, you can create something, but in the Fringe.js, you have something out of the box.